let's see an example where we can't actually go without loops. This is actually going to be another mini project, a very fun project actually. We will create a MATLAB script that will play a sound at a given frequency through your speakers or headphones. Just a warning before we start, turn down the volume when you run your projects, because if it's too loud you may not like the sounds that you hear. Not all frequencies are pleasant. So we need an equation that will generate our sound and some initial conditions. Our initial conditions will be a frequency, so we will actually have many frequencies. So frequencies equal to, we are going to start with one single frequency, 1000 Hertz. We need the duration of the sound, so 1 second. We need an amplitude, 1 again. We need the sampling rate, which is 44,100. And we also need the sampling period, which is 1 over the fs. And we need the time vector. The time vector will be from 0 to t to the duration. So we will get some vector automatically generated based on our duration and our sampling period. Now, after we do this, we need to calculate our signals. To calculate the signals, we need to use an equation. So the equation for the signal is amplitude times the cosine of 2 times pi times the frequency times t. Now t is a vector, and since it's a vector, as you can see, it has 44,000 elements in it. Our signal is now also 1 by 44,000. Now, in order to play this signal, you have to use the sound function and give it two arguments, the signal and the fs. Now, if you run this, a sound will be played through your speakers or headphones, so be careful with the volume. Run it. And there you have it, the signal. Now, from this piece of code that we have, the only thing that we need to do to generate another frequency is to simply change the frequency. If we change it to 5000 Hertz, we will get a new sound, a different more high-pitched sound. What if we want two signals to be played one after the other of two different frequencies? Well, first we have to recalculate the signal for the second frequency. Now, if we keep this at 1000, here we will calculate and play it for 1000. Then we need to say again signal equals the same thing times the new frequency 5000 Hertz, for example, and we need to also replay it. Now, if you run this code, you need to actually pause between both sounds, because otherwise they will be played at the same time. So here we need to pause for the duration of the first sound. If you run this code, you will get two signals, you will hear both signals played through your speakers, but this is not effective. And here is where we are going to use a loop. So I'm going to delete this, and I'm going to place this part of the code inside a for loop. So for I equals to from 1 to the length of the frequencies, since the frequencies is what's going to be changing, and all right. Now, if you rerun the code, it's still going to work just like it did so far, since we have only one frequency. But now, if you create a vector of frequencies, so let's give it two frequencies, 1000 Hertz and 2000 Hertz, it's not going to really work, because here we need to specify that we are looking at each individual frequency for each iteration of the loop. So here we are going to say frequencies of I. So here we are going to calculate the signal for the first frequency. We're going to play it. We're going to pause the code execution while we are playing it. Then we will come back, and the signal will be now recalculated for frequency of index 2, which is the second frequency. That frequency will be played, we will pause, and the code execution will end. Run it. Great. Now, what you can do to make this a bit more interesting is you can say start from 500 Hertz, increase by 500 Hertz until you get to 20,000 Hertz, and change the duration to something smaller, like 0.0 0.2 seconds. And if you run this, you will actually play all of the frequencies through your speakers. So run it. And there you have it. All of the frequencies in the range from 500 to 20,000 were played on your speakers with an incrementation of 500 hertz between each frequency. And all that thanks to one single loop. If you had to do this without loops, you had to manually recalculate each of the signals. And if you have 2 or 3 signals, yeah, you may be able to do it. But if you have, as you can see, our frequencies is 1 by 40, so we have 40 different frequencies. You have to rewrite these 3 lines of code 40 times in order to do the same thing that we just did with this single loop. We can go a step further and we can actually save all of the signals that we have just created. To do this, we need to save each signal in a matrix on a new row of the matrix. So we have to create a matrix. So let's call the matrix signals and let's pre-allocate a memory for it. So the matrix will have as many rows as the frequencies that we have. So the rows will have length of the frequencies, and the columns will be equal to the time. So time. This will generate a matrix that has 40 rows. Each row represents every specific frequency, and the columns of the row, the values for each row, are the sound itself for each time point. Now, in order to save this signal, we have to address the signals matrix. We're going to address the rows. So our rows are I. We said that the rows are the frequencies. So I. For the first iteration, we're looking at the first row, and we want to save our results in the whole row. So we are saying take the current, so signals of I, take the current row of the signals matrix and give it the current signal, just like that. And if I run this, I will suppress the playing of the sound. If we run this, as you can see here, we have a matrix signals 40 by 8,821 elements. So this matrix now holds all of the signals that were generated by our for loop. So with just one loop, one equation, and one vector of values, we generated a whole matrix of many different variations of the results of that one equation. Even if you find a way to do the calculations without a loop, you will not find a way to play all of the sounds individually without a loop, and it won't be as readable as this simple for loop. That is unless you write the sound function manually 40 times for each of the frequencies, of course. So let's quickly document this code and move on to the next example.